So we will be talking about the basic physics or the physics of ionizing radiation. So radiation comes from the root word radiate, in which it means to proceed in a direct line from or toward a center, to send out rays or shine brightly. So radiation simply means something that is radiated or energy that is radiated in the form of waves or particles. So radiation can be thought of as the transmission of energy through space. There are two forms of radiation: electromagnetic radiation and particulate radiation. Both forms can interact with matter and transfer their energy to the matter. So electromagnetic radiation has no mass and moves through space at the speed of light. Electromagnetic radiation can be described by two models: wave model and photon model. So electromagnetic radiation is a pair of perpendicular time-varying electric and magnetic fields traveling through space with the velocity of light. So the distance between maxima and of the electromagnetic fields is the wavelength, and the frequency of the wave is given by the velocity divided by the wavelength. So yeah, for the photon model, electromagnetic radiation can also be described as discrete packets of energy called photons. The energy is related to the wavelength in the wave model through Planck's constant and speed of light. So yes, there are the pictures. So for ionizing electromagnetic radiation, EM radiation with wavelengths shorter than 100 nanometers can remove electrons from the outer atomic shells. This process produces ions. Ions can interact with living tissue to produce biological damage. A major source of ionizing radiation is nuclear transformation. So there's human transformation and the nuclear transformation. So gamma rays are electromagnetic radiation resulting from nuclear transformation. So the production of X-rays are produced when charged particles are decelerated by a strong electrostatic field, such as that found near the nuclei of heavy metals. So particulate radiation, changed particles are emitted from the atomic nucleus at high energy in some nuclear transformations. These include alpha and beta particles. Uncharged particles or neutrons are produced by fission or other nuclear reactions. Both types of particles produce ionization. So these are the alpha particles. The beta particles. So concept of physical half-life: radioactive nuclei undergo disintegration at a rate that is proportional to the number of untransformed nuclei present. The physical half-life is the time required for one half of the remaining nuclei to transform. The half-life is characteristic if the radionuclide. So yeah, this radiation exposure, dose, and quantity. Exposure is an index of the ability of a radiation to field air. Dose is a measure of energy imparted to matter per unit mass. Quantity of radioactive material is expressed as activity, the number of nuclear disintegrations that occur in a sample per second. So this and this. So equivalent dose. For the same absorbed dose, different forms of ionizing radiation can have different biological effects. Equivalent dose attempts to normalize these differences. So equivalent dose is the product of dose and a modifying factor called quality factor, which reflects the relative biological effectiveness of radiation, as you can see is a formula. So quality factors are indices of the relative biological effectiveness. So it is a complicated function of type of radiation, energy, and the biological system under consideration. So here, quality factors. So for effective dose is intended to reflect the total biological effect given exposure on a human. Here's the formula. Yeah, okay. So this is the unit of equivalent dose and EDE. So genetically significant dose is an index of potential genetic damage to a population due to irradiation of some members of the population. So yeah, sources of ionizing radiation, cosmic rays, and naturally occurring radioactive elements, medical X-rays and nuclear medicine studies, and man-made radioactive materials and radiation sources. There, as you can see. So that would be all. Thank you. I got this source from a PowerPoint by Robert E. Remsman of Duke University.